Okay, this is the main division bar, and so when you divide fractions, you flip the fraction you're dividing by upside down and you multiply. So I'm just going to rewrite this over here upside down. And then I'm going to cancel from the top to bottom. So 6 goes into 6 once, into this 4 times. And nothing, well, let's see, actually, yeah, nothing else can cancel. And so I'm left with 4 times x plus 1 on the top and x plus 2 on the bottom. Okay, I'm going to rewrite this, but the first fraction just gets written down like it is. But then I change this to a multiplication by flipping this upside down. And then I'm going to factor while I can. On this, I'll put this down here, but I'll factor out a 3. And then I'm going to cancel. This cancels with this. This x cancels. And 5 goes into 5 once and into 24 times. So we have just a 4 left up top and a 3 left on the bottom. Okay, because we have separated fractions in the numerator and denominator, we can't flip one of them upside down. Instead, we're going to get rid of this denominator by multiplying everything by the LCD, which is x. So I'll multiply this by x, this by x, this by x, and this by x. So when I multiply this by x, I get 3x. When I multiply this by x, the x's cancel and I get negative 4. When I multiply this by x, I get 6x. And when I multiply this by x, the x's cancel and I get negative 8. But then this is factorable. I'll take out a 2 and we've got 3x minus 4. And then this cancels, so we're going to be left with 1/2. Okay, because we only have a single fraction in both the numerator and denominator, I can just flip this one upside down and multiply. So I'm going to write this the way it is. 4x plus 7 over 3x minus 2. And I'll change this to a multiplication by flipping this upside down. So, and I'm going to factor while I do it. This I'm going to factor, but I'm going to put down here. So I can take out a 3. When I take out a 3, I'm left with 4x plus 7. And then I'll factor this, and I'm going to put it on top. But I'll factor and take out a 2. And I'm left with 3x minus 2. And then I'll start canceling. 4x plus 7 cancels. 3x minus 2 cancels. And we're left with 2 over 3. Okay, because we have multiple fractions in the numerator, I can't just flip the bottom upside down. I gotta multiply through by the common denominator. So my denominators are x, y, and xy. So xy is the LCD. So I'm going to multiply this by xy, this by xy, and this by xy. And then what will happen is this x will cancel, this y will cancel, and that cancels. So we're left with 6y minus 5x over this. But I'm going to factor this so I don't have to do it in a separate step. This is the difference of two squares. So we're going to get conjugate pairs. It's 5x plus 6y times 5x minus 6y. Now, this and this are opposites. They're identical but backward around a negative. So I can cancel these as long as I pop on a negative. So since everything canceled out up top, we have a 1, and we have this on the bottom, and don't forget that negative. So we have a negative 1 over 5x plus 6y. Okay, because we have multiple terms in both the numerator and denominator, I can't flip anything upside down. I have to multiply that by the common denominator of x, which is that right there. So I'm going to multiply this term by x, this term by x, this term by x, and this term by x. This gives me an x squared. This x cancels, and we're left with plus 8x plus 7 in the numerator. Here we have, this gives us an x, and this x cancels, and we have plus 1. But this is factorable up top. the top becomes x plus 7, x plus 1 over x plus 1, and this cancels, and we're left with x plus 7. Okay, we're going to factor, and there's 4 terms here, so I'm going to try factoring by grouping. I'll group these two together as if they're a separate problem, and I'll take out a 2a. That leaves behind a 4a minus 3c. So right off the bat, I'll leave a big space, and I'll put 4a minus 3c again, because whatever I leave behind here, I have to leave behind here. Then I'll think about what I need to put there, so when I distribute, I get back to those. And it looks like a negative 3b. And just double check it works. Negative 3b times this is this, negative 3b times that is a positive 9bc. So now this is the common factor. So it comes out 4a minus 3c, and it's going to be multiplied by 2a minus 3b. Again, I have 4 terms, so I'm going to try factoring this by grouping. I'll group these two together as if they're a separate problem, and I'll take out a 4r. And that leaves behind a 3r plus a 2b. So I'll leave a big space, and I'll put 3r plus 2b down again, and then I'll think about what I need to put here, so when I distribute it, I get back to those. And it looks like a negative 5c. So here's my common factor, and that comes out 3r plus 2b, and we're left with 4r minus 5c. Here there's no leading coefficient, so I'm simply looking for factors of 35 that add up to 12. Here I have no leading coefficient, so I'm looking for factors of 42 that add up to negative 13. Oops, I'll just put it the way I wrote it. Here I'm looking, there's no leading coefficient, so I'm looking for factors of negative 40 that add up to positive 6. So positive 10 and negative 4. For number 12, there's no leading coefficient, so I'm looking for factors of negative 48 that add up to negative 2. So negative 8 and positive 6. There's a lot of ways you can factor this. You can multiply these outer two numbers and end up factoring by grouping, but I'm going to try it without that first. I'll go 2x and x, because those are the only possibilities. And this has got to be 14 and 1 or 7 or 2. I will try 7 and 2. If I put the 7 here and the 2 here, what that does is it gives me 4 on the outside and 7 on the inside. 4 and 7 do give me a difference of 3. I got to put the plus here because I need a positive 7 and a negative here. That gives me a negative 4 plus 7 is a positive 3x. And of course, those multiply to negative 14. I'll try again this using this method again. The only factors of 2 are 2 and 1, so that's easy. I got to put 2x and x. But this could be 12 and 1, 6 and 2, or 4 and 3. But because it's positive, I know my outer and inner have to add to this. So if I put the 4 here, that's going to give me, and that means I got to put the 3 there. That's going to give me 8 on the outside and 3 on the inside. And 8 and 3 really do add up to 11. And these both have to be negative in order to multiply to a positive 12. And again, I get negative 8x on the outside, negative 3x on the inside gives me this. Now this is a bit tough because you don't know for sure if it's 8 and 1 or 4 and 2. 4 and 2 seems more likely to me, so I'm going to try that first, but I might have to go back and change it to 8 and 1. The only possibility for this is, and by the way, these both have to be negative in order to multiply to a positive but add up to a negative. So now I know I'm adding to 10. Well, if I put 3 here, that'll give me 6 here, and 1 here, that'll give me 4 here. So let's try that. 3 and 1. That gives me 4 on the outside and 6 on the inside, and that adds up to 10. And of course, these multiply to positive 3. Okay, this is a tough problem because we don't know if this is 6 and 1 or 3 and 2. I'm going to guess it's 3 and 2, but I might be wrong, and I might have to go back and change this. So I'll do this. And this is tough because I don't know if this is 12 and 1, 6 and 2, or 4 and 3. But I do know that both of these are negative, and that my inner and outer then have to add up to 17. So if I can't put any even numbers here because that would create a GCF, and there's no GCF here. So if I'm going to do 4 and 3, I got to put the 4 here and 3 here. So let's try that. 4 here and 3 here. That gives me 9 on the outside and 8 on the inside. 9 and 8 add up to 17, and this multiplies to positive 12. This is the difference of two squares. This is 2x squared minus 9 squared. So we're going to end up with conjugate pairs. 2x plus 9 times 2x minus 9. This is the difference of two squares. This is 3x squared minus 5y squared. So we're going to end up with conjugate pairs. 3x plus 5y times 3x minus 5y. This is the sum of two cubes. The first thing you got to do is identify what the cube roots are. So this is x cubed plus 3 cubed. And then you're going to make a small parentheses and a large one. The small one gets the cube root items. And then this goes square, product, square. So square of this is x squared. The product of the two is 3x. And then the square of this is 9. And then we'll use SOAP. Same, opposite, always positive. Okay, again we have a sum or difference of two cubes. So first identify what the cube root items are. This is 5x cubed minus 3y cubed. And then you're going to make a small parentheses and a larger one. Okay, the small one gets your cube root items, and then you're going to go square, product, square. So we'll square this, and then we'll take the product of the two, and then we'll square this, and then we'll use SOAP. Same, opposite, always positive. There's 4 terms here, but you can't do this by grouping. If you try to group these two together, you get stuck. But if you notice, this is a perfect square. And we can write it as such. This is minus 6 squared. And this is a perfect square. So now we have the difference of two squares. And with the difference of two squares, you always end up with conjugate pairs. It's always the first item, x minus 6, plus the second item, times the first item, x minus 6, minus the second item. Here we have a recurring element, so I can use substitution to make this look a little simpler. I can call x, or let's say, not x, because that we're using x, but y is equal to x minus 5. And what that means now is we have y squared plus 6y minus 40. And we can factor this as y plus 10 times y minus 4. And now we got to resubstitute y with x minus 5. So this becomes x minus 5. So we have x minus 5 plus 10, and this becomes x minus 5. And we have minus 4. And so when we combine like terms, we'll get x plus 5 times x minus 9. All right, this is already factored and equal to 0, so it's the opposite of this and opposite of this and this over this. So we have a negative 7 and a positive 3. This is already factored in equal to 0, so it's the opposite of this and this over this, so positive 3 over 2 and negative 3 over 1. This doesn't contribute to the solution because it's not a variable and we can ignore it. So we get positive 2 and negative 4. This x out here tells us x is equal to 0. So we have 0, negative 3 over 2, and negative 2 over 1. So 0, negative 3 over 2, and negative 2. Don't put the over 1 though. This 3 can be ignored, but the x can. This x tells us x is equal to 0. This tells us positive 5 and negative 2. Before we can figure out what this is, we need to factor this. So this factors as x minus 5 and x plus 3. So this gives us a positive 5 and a negative 3. We need to factor this first. So this is 2x and x, let's say minus 2 and plus 1. This tells us it's a negative 1 over 2. And this tells us it's a positive 2. Before we can solve this, this needs to be equal to 0. So that's got to be our first step. Move this over. And then we'll factor. So 5 and 1, let's see, plus 5. That gives us a negative 2 on the outside, positive 5 on the inside, and that adds up to that. And this multiplies to negative 5. So this tells us it's a negative 5 over 2 and a positive 1. Our denominator is not allowed to be equal to 0. So x cannot be equal to 0. To write this in set notation, we'll open up a set and say all the values of x such that x cannot be equal to 0. This is not a variable, so the bottom can never be equal to 0. So there's no restriction on x, so x can be all real numbers. This tells us that x cannot be equal to positive 1 over 2. It's the opposite of this and this over this. So we write this, we open up a set, all the values of x such that x cannot be equal to 1/2. This is negative 3 over 4. So x, the domain is all the values of x such that x cannot be equal to negative 3 over 4. Okay, for 35, let's cancel this here. And then we'll also cancel the x. And then we'll cancel, we'll say 2 goes into 2 once and into 8 4 times. So we end up with just 4. These are opposites, and you can cancel opposites as long as you pop on a negative. So you do that. And then 4 goes into 16 4 times, so we end up with, everything cancels out of the bottom, so we just end up with negative 4x. That x is still there. I'm going to factor both the top and the bottom. The top factors as x plus 4, x plus 3. The bottom cancels as x plus 3, x plus 1, and then we cancel this and we end up with x plus 4 over x plus 1. This is the difference of two squares. This is 2x squared minus 5 squared. So we're going to end up with the conjugate pairs. 2x plus 5 times 2x minus 5 over 5 minus 2x. And these are opposites, and you can cancel these opposites as long as you pop on a negative. So our answer, I'm going to distribute this negative so I can simplify this, but we're going to end up with negative 2x minus 5. Okay, because this is a multiplication, anything on top can be canceled with anything on the bottom. So I can start by canceling 2x minus 1. I can cancel 3x minus 2. And I can cancel x plus 6. And we're going to be left with 3x plus 4 over x plus 3. Okay, this is going to change the multiplication. We're going to flip this upside down. But so I don't have to write stuff. I'm going to cancel within each fraction first. So I don't have to write more than I need to. So this cancels with this, and this cancels with this. And so what I'm left with is x minus 3 over x plus 4. Change this to a multiplication by flipping this upside down. And then this cancels with this, and we're left with x minus 3 over x minus 8. Okay, I have to factor every single one of these. So factor this, and we have x plus 4 times x plus 3. Factor this, and we've got x plus 3 times x plus 2 times, factor this, and we've got x minus 5, x plus 2, and factor this, and we've got x plus 4 times x minus 3. And now I'll start canceling. This x plus 4 cancels. This x plus 2 cancels. This x plus 3 cancels. And the only thing we're left with is x minus 5 over x minus 3. And I got to get rid of the parentheses. Because this division bar implies that you have parentheses around everything on top and everything on the bottom, so you no longer need them to be simplified. Okay, I've got to factor this and this, and I'm going to change this to a multiplication and flip this upside down. So I'll do that all in one step. So we have the x plus 4 times x minus 5, and then I'll factor this. That's x plus 4 times x plus 2. And I'll change this to a multiplication by flipping this upside down. So this is going to go down here, x minus 8 times x plus 1, and then I'll factor this and put it up here. So this is going to be x minus 8, x plus 2. Now that this is a multiplication, anything on top can cancel with anything on the bottom. So let's start there. And we have an x plus 2 that cancels, and we have this x minus 8 that cancels. So we're left with x minus 5 in the numerator and x plus 1 in the denominator. Okay, let's look at the x. X has a power of 3 here and power of 2 here. 3 is more, so that's part of our denominator. And then let's look at the x plus 4. They both have a power of 1, so we just got to include it once. For this, let's look at the x plus 8. We have a power of 1 and a power of 2. 2 is more, so that's going to have 2 in our denominator. And then we'll look at the x plus 5. It has a power of 3 here and a power of 2 here. 3 is more, so that's going to be part of the denominator. For this, because we have a common denominator, we simply add the tops and keep the denominator. We have a common denominator, so we got to subtract. But remember, the negative is going to distribute. So we're going to have 3x minus 5 minus x plus 4. Be careful, that's where people make a mistake. But it's all over 2x plus 3. And then when you combine the numerators, 3x minus x is 2x, and negative 5 plus 4 is a negative 1. That can't be simplified, so our final answer is 2x minus 1 over 2x plus 3. Okay, for this problem, in order to get our common denominator is 12. So what I have here is, let's do this. I have 2x plus 5 over, let's do it like this. I'm going to make this over 12 and over 12. On this, I have to multiply by 4, so I have to multiply by 4 up here, and I'll get 8x plus 20. On this one, to get to here, I have to multiply by 3. So I'll multiply by 3 here, and I'll get a 3x plus 3. So now, I'm going to combine like terms, and I'll have 8x plus 20 plus 3x plus 3 all over 12. and this is going to turn into a 28x, but not 28, it's going to turn into an 11x, that's 8x plus 3x, plus 23 all over 12. Okay, my denominators are totally different, x and x minus 1. So my LCD is x times x minus 1, just multiplying them together. My fraction started out with 5 over x plus 3 over x minus 1. Those are the original fractions. But I need to multiply this in order to make it look like the common denominator. I need to multiply by x minus 1. So I need to do that in the numerator as well. On this one, in order to make it look like this, I need to multiply by x. So I need to do that in the numerator as well. Now I'm going to distribute this 5, and we're going to get 5x minus 5, and then I have this plus 3x over x times x minus 1. And this is going to simplify and give us 8x minus 5 in the numerator times x minus 1. That's it. Okay, we have a rectangular garden, so let's start by drawing that garden. And we have x for the width, and the length is 4 feet less. I'm subtracting 4 from 4 times the width. Well, 4 times this is 4x, and it's 4 feet less than that. So that's the length. And the area is 48. Well, a rectangle, you multiply the length and width to get the area. By the way, this is going to be worth a half a point. So now we're going to multiply this to get the area. So that's our equation. And that would have been worth a half a point. Now let's solve this equation. I'm going to distribute this, and we'll get 4x squared minus 4x. I'm going to bring this over all in one step because this is a quadratic. So I'll bring this over, and we'll have minus 48, and now it's equal to 0. The first step in any factoring problem is to factor out the GCF. So I'm going to take out the 4. So I have 4 times x squared minus x minus 12. This is not going to contribute to the solution, but I need to factor this. So this is going to be x minus 4, x plus 3 equals 0. Let's bring this up here. This is nothing, but this tells me x is equal to positive 4 and negative 3. But the x stands for a physical dimension, which can get as small as 0, but it can't go negative. So this doesn't make sense, and I have to throw it out. So now I know that my x is only equal to 4. That's the width. To find this, the length, I go 4x minus 4. 4 times 4 is 16, minus 4 is 12. So the dimensions are, and by the way, this would all be worth a half a point. And then I have the dimensions are 4 feet by 12 feet. And that would be worth a half a point. And that's it.